So hello everyone, welcome to this video. This is lecture number 16 and part 8 of this solution for this book Electricity Magnetism by Vasudev Ghosh. Okay, we already covered up of chapter 1 and the covered chapter 2 of question. Chapter 1 already covered and chapter 2 question 1 to 8 already covered in the previous lecture. You can go through the description box, links given in the description box. Okay, and in the meantime we already discussed about the question of the electrodynamics by DJ Griffith of chapter 2. We already covered up this portion also. You can go through the description box, you can get this solution video in this channel. Okay, in this video I want to discuss the question number 9 to question number 19 of chapter 2 of this book Electricity Magnetism by Vasudev Ghosh, right? So let's start with this question number 9. Question number 9 says consider a non-polar dielectric material of dielectric constant 4. This is a non-polar dielectric constant and the density of these molecules is like that and molecular weight is 59. Okay, so find out molecular polarizability. So you need to find out molecular polarizability. You know the Clausius-Mortier equation from this book. You can get this equation, that is alpha equal to 3 epsilon naught by n k minus 1 by k plus 2, where n is the molecular number density and k is the epsilon by epsilon naught and alpha is the molecular polarizability, right? So if you put this value, that is k is 4 minus 1 and 4 plus 2, that is you get these 3 by 4. So you 2 by 3 by 6, they are cancelled out, 3 by 2, and this is epsilon naught v by na, and v is nothing but mass per density, because density equal to mass per volume, so volume equals to mass per density. Now if you put this value, that is 3 by 2 epsilon naught and this is 59 na and 1000, you will be get this answer. Okay, go to the next one, that is consider a dielectric hemisphere with its plane surface in the xy plane. It was polarization, that this is the polarization in the z direction. Find the volume and surface density of this. You know this the volume charge density equal to minus grad of p. P is the polarization. So if you put this value of polarization, you will be get that k, this is the constant, so del del z of this constant gives you 0. So finally you got the volume charge density 0. For the surface charge density, this is the p dot n cap. N cap is this direction of the surface. So the for the plane surface, the direction of n cap is in the downward, that is minus k cap. So that's why this is minus k cap, right? So this is minus k cap. So for plane surface, if you put the n cap is minus k, so you will be get minus a. For the curved surface, this k dot n cap, k is along that direction, k cap, the angle between them is theta, so this is cos theta, so you will get a cos theta, where theta is the angle between n cap and z direction, right? Go to the next question. Consider a dielectric sphere of radius a with uniform polarization p equal to p k cap in the z direction. Electrically, it is eventually to the system to uniformly charged sphere of radius a with the equal and opposite charge density and slightly displaced. So these are slightly displaced each other using the idea of calculate field and potential due to polarization sphere. So the resultant field at this will be q by 4 pi fq by this aq into this. This is the potential within this sphere. You know this expression. This is the potential within this sphere, and this is also within sphere. So you will get this expression where delta can be written as O2a minus O1a. You can see here this vector equal to nothing but this O2a vector minus O1a vector. So this can be written as delta. Now the polarization is dipole moment per volume. Dipole moment is charge into displacement per volume. So this electric field inside will be can be written as, because this q into delta is nothing but this p into this volume. So if you put and rearrange, you will be get this electric field within that region, right? And for outside, this dipole moment is q into delta, that is the total polarizability, and the corresponding potential will be this, because this is the potential for a dipole. This is the potential for a dipole, right? If you don't know this relation, you can go through this description box. There is a video for class 12 level class. In this class, this derivation was obtained. Okay, go to the next question, which says the space between two concentric spherical conductor. These two are spherical conductor with radius r1 and radius r2. We take just radius, filled with inhomogeneous dielectric constant. In these two concentric pair, there is a inhomogeneous dielectric constant which is like that 1 by a minus br, where a and b are constant. A charge q is placed on the inner sphere. Within this inner sphere, q charge is placed and outer is grounded. Determine the volume charge density of the polarization charge. So from Gauss theorem, you know d dot ds equal to q enclosed. So d into 4 pi r square. If you take this as a r within the region, so you will get displacement vector. D is a displacement vector. You know, d is a displacement vector. Displacement vector. From displacement vector, you know the electric field can be obtained d by epsilon. This can be changed into epsilon naught with multiply this term, will be get 1 by k term, and putting the value of k, you will be get this expression. This is the expression of electric field. Obtaining this electric field, you can find out the polarization by this relation d minus this, because you know this displacement vector is nothing but polarizability plus epsilon naught e. So from that you get the p equal to like that. Okay, so and d equal to epsilon e, so e can be common and epsilon not common, this will be k minus 1. Putting the value of electric field, you will be get this equation. This is the polarization. Now goes into the volume density of the polarization of charge, that is minus divergence of this. So in spherical polar coordinate system, this divergence will be del del r of r square into ar. You know this term will be del del r of r square into ar, like that. Okay, so r square into ar means the coefficient with the r cap. Putting this value, you will be get this expression, and derivative with this constant is 0, only you will be get b. I think clear. This is the volume density of polarization. Go to the next question. A conducting sphere of radius a placed in a homogeneous isotropic dielectric medium of dielectric constant k. Determine DEP, displacement current, electric field, polarization inside the dielectric. Hence determine the volume and surface density of polarization charge. Right. So from Gauss theorem you get the displacement vector. From displacement vector we can find out the electric field, and from electric field we get the polarization, and this is the polarization. After getting the polarization, we can find out the density of polarization, that is divergence of p. So this will be like that. And for surface charge density, this is p dot n, and this is n along the r cap, because of the spherical symmetry you will be get this expression. Clear. So this is a constant, that's why this is 0, and for this you will be get this expression, right? I think you can understand this thing very well. Go to the next question. Their potential inside a dielectric sphere of radius a permittivity epsilon as this. The potential is given. Find the volume density of the polarization charge. From potential you can get the electric field. From potential you can get the electric field minus grad phi. In this spherical polar coordinate system, this grad is r cap del del r and theta cap 1 by r del del theta, phi cap del del phi cap r sin theta del phi del r, right there. There is no psi component, you will be get only r and theta component. So phi of r, if you derivative with respect to phi, you will be get a theta, and if you derivative with respect to theta, you get a r. So these are cancel out, a taken as a common, so you get theta r cap, and this is theta cap. So the polarization is nothing but this is the polarization So put the value of E, you will be get this expression. So the volume density will be nothing but divergence of this. So calculate this divergence. Uh, Calculate this divergence 1 by r square del del of r square rho r and 1 by r sin theta del del theta of this, and this is phi. This part is 0 and rho r is theta and pr is theta and p theta is 1. So this derivative will be cos theta and this derivative will be 2r. So finally we got this expression, that is the volume charge density of polarization. Volume charge density of polarization is this. Next question. Consider a dielectric cube of side A. This is a dielectric cube of side A and center at a origin. The center of this dielectric this cube as a origin. It carries a frozen polarization. This is a polarization within this cube is like that. Okay, polarization with this is like that. Find polarization volume and surface charge density show that total polarization charge is 0. So this polarization charge density equals to minus divergence of P. So here P is AR, so divergence of R is 3, so you will get minus 3. Now the polarization of surface is P dot n cap. Here this is 6 surface, so you need to find out the 6 surface charge density of polarization. For x equal to minus a by 2, that's mean in the back surface this n cap will be minus I cap. So if you put this is minus I cap, it will minus ax and the value of x is minus a by 2, so you will get a by 2. Similarly, in case of x equal to a by 2, that is front surface, the n cap is the I cap, so this is a r dot I cap, that is ax, and the value of x is a by 2, you will be get this. In case of the y axis, in the same, for y equal to minus a by 2, this is minus j cap, you will be get minus a, and put the value y is minus a by 2, you will be get a by 2. In the similar fashion, you will be get for a equals to a by 2 in the function bit, and for z equal to minus a by 2 and z equal to plus a by 2. All these value are the same. So total value will be the 6 into a by 2, 3a by 2. Now the total polarization will be rho v into rho s into s, that is the volume, and this is the volume charge density, and this is the surface, and this is the surface charge density. So this volume charge density is minus 3a, we already got this is minus 3a, and the total volume is aq. Total volume is aq, and the surface charge density is for one surface, the surface density is a by 2, and this corresponding surface is a square, and there is 6 surface, so multiply by 6. So finally you get, will be get this relation. Clear? You will be get this relation, that is the 0. Next question. Consider a interface z equals to 0. Z equals to 0 as the interface between two dielectric, region 1, that is 1 z greater than 0, this is region 1, this is region 2, where k1 equals to 4 and k2 equals to 3. Where electric field in this medium 1 is given. Suppose this is the electric field, E1 is given. You need to find out this E2. If this is E2, you need to find out this E2. Clear? So for that you need to know these two boundary condition. First one is the normal component of this displacement vector is equal to the surface charge density. Okay, normal component of displacement vector is surface charge density. Since there is no surface charge density, so this will be 0. So displacement vector can be turns into this electric field by the multiplication of epsilon. So you will get this expression, and this perpendicular means this is the normal component of electric field. So normal component of electric field of in second side, that is region 2, equal to epsilon 1 by epsilon 2 in the normal component of the electric field in region 1, right? So if you multiply epsilon naught in both sides, you will be get k1 by k2. So k1 by k2 is 4 by 3, and the perpendicular component of electric field 1 is 3. because perpendicular is the k cap, so in this k cap there is 3, so you will be get this is 4, right. So the perpendicular component of this electric field change as a 4. In the second boundary condition says that the tangential component of the electric field will be continuous. That means tangential component in the region 2 is equals to tangential component of region 1. So the tangential component is means the perpendicular to this direction. This is the perpendicular to this k direction is I and j. So I and j will be the same. So I and j will be same, only k as a change from 3 to 4. Clear? So that's why the electric field and region 2 will be like that. Go to the next question. A dielectric sphere of radius A carries a surface charge density of polarization this. This is a surface charge polarization charge. So that the external point this equivalent to point dipole of this. From the external point this is equivalent to a dipole of like that. So from polarization surface density of polarized charge, that is this sigma p equal to p dot n cap. You know this sigma p is sigma 0 theta and this is p dot n cap. The n cap means there will be cos theta, cos theta cancel out. So this p will be k0 k cap, because if you take this k cap then only possible this n dot k is taken as a cos theta. So you will be get like that. Okay. So after that the dipole moment is nothing but the polarization into volume. Polarization is sigma 0 k and volume is 4 third pi a cube. So you will finally will got this relation. Next question. A block of carbon is uniformly polarized of this. This is a polarization. Its density of carbon is this. What will be the separation between positive and negative charge center in this carbon atom? So you need to find out the separation. For separation, you need to find out the dipole moment. So you can write this polarization is equal to total dipole moment per volume. So total dipole moment means you need to multiply this number. We will be get this number. Small m is the mass of this carbon and this is the molecular mass. So you will be get this number into atomic Avogadro number. That means this is the total number of dipole, and for each dipole the charge will be 6e, because a carbon there is 6 protons. So 6e into L is the charge into distance, that is the dipole for a one single dipole, and this is the number. So this will gives you total dipole moment, right? So after that m small m by v is rho and capital M is taken here and Na in 6 EL. So finally L, this is the separation will be like that, P into M rho Na 6e. P is 4.8 this, M is the atomic mass 12, rho is given, Na is the Avogadro number 6 and E is the electron share. After putting this value you will get this equation or this expression, right? Go to the next one. A right circular cone of semi-vertical angle theta, this angle is theta, has uniform polarization P parallel to its axis. This is the polarization of which is along to this axis directed from vertex to base. This is vertex and this is base, vertex to base. Find the polarization polarization charge on the plane and curved surface. So you need to find out the polarization charge of the plane and curved surface, and so that the total charge in this surface is 0. So that the total charge in this surface will be 0. So if you take this P as along the k direction or z direction, that is P equal to P k cap. So the polarization charge on the plane surface will be P dot n cap, P dot n cap. So P equal to P k cap and n cap also k cap for plane surface. So finally you get this is P, right? For curved surface P dot n cap, P is like that and n is perpendicular like that. So if you draw this parallel here, you can see here this total angle will be theta into pi by 2. This is the pi by 2. So you finally you got this is theta pi by 2 plus theta, and cos pi by 2 plus theta is minus sin theta. So in the curved surface this will be the charge density. Now if you want to find now if you want to find out the total total charge means total charge. So total charge means charge density into area. So for plane into area is plane, for plane into area, if you take this radius as a r, this radius as a r, and this is as a l, no, if this is r, I think we can find out this is r sine theta, right? This l is r sine theta. If this is l, this is perpendicular, so l is r sine theta. So the for plane surface this will be sigma into pi r square, and for curved surface, sorry, curved surface, the area will be 1/3 pi r l, I think pi r l, like that. Is this right? Pi r l. What is the area of curved surface of cone? Area of curved surface of cone. What is the area of the curved surface of a cone? Just forget. Area of curved surface of a cone. Curved surface of a cone. What is the area of a curved surface of a cone? This is the curved surface of a cone, pi r l. I think this is right, pi r l. If this is pi r l, you can write this sigma is the p into pi r square, and this is minus p sine theta, and pi r l, actually sine theta is perpendicular by hypotenuse r by this l, so l is r by sine theta, l is r by sine theta, r by sine theta. Okay, so this sine theta can be out. So pi r l, l is r by sine theta, so as sine theta cancel out, this pi r square p and this pi r square p, finally you will get 0. Clear? I think clear. So this is the total charge of this surface. So that's it for today. This is all about me, and this is my contact details, and this is my YouTube channel details. Go to this channel, you will get others videos like that, and share this video to your friends so that he or she also get benefit from this video. And subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So that's it, take care, we'll meet in the next video as soon as possible. Thank you.